Hey there, everybody. So I won't always do this, but on occasion, I will make a quick video going over the practice and problem solving, particularly if I think it's one where I might do a little instruction as we go along. So this is the case on this one. All right, so these are the answers to page 123 and 124. And you can see what I have done is I wrote my answers on separate paper and I just took little pictures of it. You can do that as well. If you do your homework on paper and take a picture of it, it'd be great if you would just copy and paste that image onto a Google Doc and then hand it in to me that way. If you have any questions about how to do that, just jot me a quick email at ebailey@rsu14.org and I'll run you through the process of doing that. Okay, so anyway, number one, you can see I just kind of did this a little bit differently. The original bill was $32. So then underneath that then would be a bar showing the discounted bill plus whatever the discount was, right? That should make sense if you think about it. The discount plus the discounted bill would be as much as the original bill. All right, so 15% of 32 is the discount, and then right here, the 32 is the original bill. All right, number 2 and 3 I put together. It says to write and solve an equation to represent the relationship. So I decided to do it this way. B, or the discounted bill, is equal to 32 minus 15% of 32. So then that's 32 minus $4.80, which ends up being $27.27. For 3, it says, well, what percent of the original bill is Chumani's bill? All right, well, 100 minus 15, that's 85%. And if you remember on my teaching video, I'm always wanting to have you think about that. Like if it's a certain percent off, what percent do you pay? So then to figure that out, I just figured real quickly, what's 85% of 32? So it's $27.20. You can see I wrote 37 to begin with. Oops, right? The correct answer is 27. All right, here's number 4. And again, I want to point out with number 4, you can see that I was not thinking of the right thing when I started this problem. I was thinking, oh, okay, maybe I need to think about 104%. I even wrote it down. But as I went along, I realized, oh, that's not the way to figure this one out. So you can see I crossed it out. I'm absolutely fine if you cross things out on your homework and that type of thing. Just don't make it too messy. But this is just practice, so don't worry about being too perfect on it. All right, so Chandler earns this base pay of $2,200, plus he earns a commission of 4% of his total sales. So 1 month he earned $2,400. Explain how we find Chandler's total sales for that month and how much were they? All right, so I want to point a few things out here. I started by figuring out what his commission must have been. So the commission must have been $200. So then here's the question. 4% of what number is equal to 200? All right, so I used a little algebra here. Right? Basically, I'm calling then the sales S. So here's what I know. 4% times S is going to equal 200. Remember that of often means to multiply. So here's the way I'd write it out in an equation. 0.04 times S. Now in algebra, because this is a little bit of algebra, when we're multiplying a number by a variable, we can just write it right next to each other. It's kind of a cool thing. Anytime a number is written right next to a variable, it's multiplication. So here's what I know. 400 times S is equal to 200. So since this is multiplication, I can divide. Note how I'm writing the division as a fraction. Right? Basically, fractions are division problems, and that makes it just a little bit easier to see. This is often the form used in algebra. All right, so when I divided 4 100ths by 4 100ths, I got S. Because anything divided by itself gives 1, and 1 times S is just S. Right, so then I figured out that it's 5,000. So what I know is 4% of 5,000 equals 200. Be good to do a double check on this. Just do in your calculator, and you can do this in your calculator, or you can do it by hand. I expect you should be able to do this by hand, but if you want to use a calculator, I'm okay with it. So 0.04 times 5,000 should give you 200. All right, so his total sales, $5,000. All right, Here's number 5. All right, so Marion gets charged 5%. She's buying this sound system. All right, so basically I solved it 2 ways. I figure, well, Marion must pay 105% in all. So 105% of 450, you can see how I wrote that out, is 472.50. Or let's say for some reason you did need to know the exact interest. Then you want to do it in 2 steps. 5% of 450 is 22.50. That's what she pays in interest. By the way, sometimes that's deductible in your taxes, which is a good reason to actually be able to figure out the interest. All right, just saying. All right, and then just add 450 plus 22.50 and you get 472.50. All right, same answer both ways. All right. All right, how about this one? Number 6. Dan paid $34.30 for a sweater. The price included a 40% markup. Find the cost of the sweater before the markup. So I'm figuring to myself, all right, Dan is actually paying 140% of the original. 100 for the sweater plus the 40% markup. So I'm going to start right off with that. So back to using the algebra. 140% of what is 34.30? Okay, I'm using S as my variable again, but this time S doesn't stand for sales, it stands for sweater. Right, so it's important to really kind of pay attention when you're looking at variables like this to what does the variable stand for. All right, so I have 1.4 times S is equal to 34.30. Right, I changed that percent to a decimal here. Right, divide both sides by 1.4. That's one way we say it. 34.30 divided by 1.4 gives me 24.50. So that's the cost of the original sweater. All right, last problem. You can see my big messy arrow here. Anyway, this jacket that originally sold for $60 was on sale for 10% off. When it did not sell for several weeks, the sale price was discounted by 40%. So what's the final price of the jacket? Then it asks if it's equal to 50% off, which you could see why you might think that, because 10 plus 40 is 50, right? But I'm hoping that you found out, no, that's not the same, and I'll try to explain why that's the case. So anyway, for the 10% off, I just figured out 90% of 60 is 54. And then for the 40% off, which it's taken off the discounted price, see how that's the same number? I'm figuring that's 60% of the 54. So that's then 32.40. All right, so there's the price after the 2 discounts. Right here would be the 1 discount. I'm just doing this to see if this is right. Well, if it's 50% off, it's 50% of, so all I did was cut that in half. And I can see right here, no, those are not the same. Well, why is that? Well, here's why. In this one, you're taking 50% off 60. But right here, the price actually changes to 54. So you don't have the same original price all the way through. In this one, you're really taking a discount of the discount. So in some ways, that ends up being actually less of a discount. Because note here, you're not taking 60% of 60, you're taking 60% of 54. So that's why you actually end up paying more in this case. Now, if that didn't make sense to you, you could rewind the video and just listen to that again. But we'll also be going over this type of thing again, right? But this is kind of important. 2 discounts, like a discount of a discount, is not the same as adding the percentages together and doing it once. All right, thanks for listening.